Bismillah ar-Rahman ar-Rahim. Students, welcome back. This is a paper, February, March 2024, 42 variant and complete paper mechanics. We are going to start. Question number one. If you look at carefully, this is given distance in meters, and here time in seconds. Okay, so if you read a question, you say that it consists of 4 straight lines, 1, 2, 3, 4. And the particle travels in 50 meters, 50 meter distance travel in first 10. It means the first 10, the distance travels 50 meters. And then it travels a speed of 2 in a 10 second. It means this is speed of 2. This is speed of 2. So it means during this motion, the speed of 2. Okay. And then come to rest for the period of 20 seconds. This means this is a 20 second you talk about. And this is a point and the stop here. Particle stops, come back, same position. Okay, and this flat track. Flat track means no motion. This is called no motion because distance remains same. So if distance remains same, there's no motion. And what a question we have: velocity of the particle during last 20 seconds. So we need to find out this. Do you know, student, for distance time graph, we have 2 rules. So distance time graph, we have 2 rules. Rule number 1, the gradient. Sorry, we have 1 rule only, for no 2 rules for it. And that is 1 rule is what? The gradient of any line, is equal to speed. And then with the other one is for knowledge velocity time graph. We have 2 rules. Rule number 1, gradient represent acceleration, and area under graph, under lines, is called distance travel. But currently we are discussing this one, distance time graph. So let's start. So first of all, he's asking this one. So what is the rule here? Gradient of speed. So gradient. So I need to find speed here, velocity. And if I need a velocity, I need a gradient. What is here? X value 60, Y value 0. And what about this? X value is obviously clear, 40. And Y value we don't know. No problem. We'll find it. And that is exactly here. So what the number here, I want to find it. Let's say this D for distance. Okay, so students, we have given one connection, which is helpful, which is this connection is given. And he's asking that, what is the method to do it? You know, this gradient I will find. And what is this coordinates, students? This coordinates is 20, D. D come from here. And what is this coordinate, students? Is a 10, 50. And what is the gradient I use? Gradient formula, actually y2 minus y1 over x2 minus x1. So apply y to d minus 50 over 20 minus 10. And the gradient is 2. So there's a 10 multiplies there. You got a 20. D minus 50, 50 goes and add. So it means distance travel is a 70 meters. So it means this is 70 meters. It means this. So this coordinate is a 70 meters. Look, I got it from here. Why? And now I'm looking for what? For velocity. Now, what's the method? Again, same story. I will use the same formula. Okay, I'm not writing now because you're familiar. So gradient means velocity is equals to y2. Let's apply. So y2 minus y1 over x2 minus x1. Okay, this is becoming negative 720. This negative 70 over 20. 0 cancel. You can say, or negative 3.5 meter per second. Okay, and negative we have to keep as it is. Logic. This he said velocity. And it's a negative sense, but if you ask magnitude, no, it's not asked magnitude. We will leave as it is. Okay, if we ask magnitude, then write 3.5 only. Actually, I just tell you, we have done it many times. When this is an observer, when particle goes away from observer, velocity positive, and when the particle come back to observer, velocity negative. And velocity negative means it's positive above and below. It means it's 100% clarity. This is a line or curve will below the x-axis because it is coming back. I think you all students understanding. I given a logic now. Let's move on. Next part. He said, sketch a velocity time graph for the motion of the whole journey. So what is 60? So what I will do, students, I will make a same situation. You see, this is the same situation. I will make it. Okay. And here I have 10, here 20, here 40, and here 60. I think you understood very well. So let's make this diagram. Copy from here and bring down. Okay. So this is condition we have, and let's try to do it. How we can do it. You know, time remains same, everything. So I copy paste. And now, you know, best technique for every point, students, you have to, this is a seconds, time in seconds. And here I got a velocity meter per second. Okay. Now, you know, what is the best technique? Get the label values. For example, what is x10? What is the velocity at that moment? It means when time is 10, the velocity is 2. So I'm writing when time is 10, velocity 2. Time and velocity. Okay, even 10, 20, time velocity is 2. Till 10 to 20, we velocity 2. But, and even 40, time is 2. At 40, the velocity again, time is 2. But this is a, you know, at this, when 62 is a 60, so velocity is not a 2. Is a negative 3 point, you know, negative 3.5. So from here to there, we have a velocity negative 3.5. And from 2 to 10 to 20, what is speed from here to here? 2, positive 2. Okay. So this data is enough to make it. Every time we have to look upon two things. It means I will make it here. So the students very clear. So first of all, you know, it's starting from 0. I could not write 0, but I tell you from 0 to 2, because 0 to 2 velocity is a 5. Sorry, this is an important part I missed. And how to find velocity of the first 10 seconds, you know, y2, what is this one? So student 0, 0. So y2 minus y1 over x2 minus x1, 50 by 10, 5. It means 0. So I missed that one. So it means 0 to 10. 0 to 10. It means if I write here like this, time is 0 till time 10. I think I have to erase this one. Time 0 to 10, velocity is 5. And next thing, from 10 to 20, from 10 to 20, velocity is 2. And last stage, 20 to 40, not 20 to 40, 20 to 40, velocity is 0. And 40 to 60, velocity negative 3.5. So this timeline and velocity, the concept is very clear and you will understand. If you have an issue, so please make this way. And you will, the chance of mistake will, inshallah, will finish automatically. So 0 to 10, velocity is 4. But let me tell you, velocity is same. 0, 1, 2, 3, till 10, velocity remains same. So this is a wrong way. This is a wrong way. I have seen some student try to do this way. Wrong. This velocity time graph, the gradient, I said before, the gradient representing acceleration. So if you make it this way, is accelerating, whereas wrong. 0 to time velocity remains same, 5, 5, 5, 5, 5. It remains 5. So it means this is a 5. 1, 2, okay, I make it 1, 2, 3, 4, 5. Same way, 1, 2, 3, 4, 5. And this is a 3, is a negative 3.5 even. Okay, 5. So students, first to 10 seconds speed is 5. So see, I will make a line parallel to x-axis till this much. You see, slightly, I think made it slightly, I think now clear. See, this much, you see? So this is a diagram is very clear. Okay, now 0 to 10 is done. Now 10 to 20, we have a 2 speed. Immediately it will come on this. So 2 is here, but I'll not start. I'll start from 10 till 20. So this straight path representing that, because velocity time graphs of velocity 2, 2, 2, 2, 2, 2, you see here 5, 5, 5, 5, 5. So first 10 seconds it remains 5, then 2, and now we'll talk about, and then it is a straight line blue, no motion, zero velocity. And then is a negative 3.5. Negative 3.5 is below. So it means I will make here, if I take a scale, so from 40 to 60. So students see 40 to 60. And I believe you got a point. And if you stop it here is okay. Or some teacher, they make it this kind of dotted line. This is also correct. Not wrong approach. Okay. If you make it, okay. If you don't make it, no problem at all. I think so. Both are correct. Okay. So this diagram is done, alhamdulillah, Rabbil Alameen, and this kind of working will help you to get it. Let's go for next. Question number 2. A particle is projected vertically upwards from a horizontal ground, okay, and speed of 2 seconds after the projectile, okay, and it is traveling downwards, okay. So it means situation is what, students? So particle is thrown from here. Naturally, it will go up first of all, and it will stop here. Naturally, last velocity is 0. Going upward, gravity is negative 10. Okay, and then it will start once again. So it will start once again from here, and it will travel. It will somewhere here. We don't know, but anyway, at this particular position, gravity is positive 10. Starting velocity 100% 0, because when it drops or falls down, its velocity, starting velocity is confirmed 0. Best technique before you start this kind of data writing is very helpful. And just as a teacher, please make diagram, and data writing is very important, and a lot of help will get from here. And it's traveling downwards. It means we talk about not going up or downwards. And that time, the velocity is 2 and time is, sorry, time is this particular time is 2 and velocity is 5. Okay, this part is clear. You see that, and what is asking for? Speed of projection. So this speed is unknown. You see, I think data will help us. Look, this all data given. Okay, so I think we can talk about while going down. Okay, while dropping. While drop. So what is data? That is enough to get a time. Sorry, this is time at this point. Okay, time for this journey we don't know. Okay, time for this journey we don't know. Hold on. Time for this journey, time we don't know. This time is my target. Okay, how? So let's start. This time you can't utilize it. Okay, but ultimate speed we know it. So let's apply. V is equal to U plus AT or GT. Velocity at this moment is 5. Starting velocity while dropping is 0. Gravity positive 10 and time is unknown. 10 will go down and 5 by 10. And time I got as 0.5 second. Wait a minute. So time I'm getting 0.5 second. It means this time is 0.5 second. Total time from here to there is a 2. Total time is 2. So from 2, if you subtract 0.5, so this time is 1.5. So it means like going up or dropping, or we can say while projection upwards or going upwards. So can I say now, student, U is unknown, correct? Last velocity is 0, gravity negative 10, and time I know now, because from this 2 subtract 0.5, 1.5. And I believe you got a point. Now V equal to U plus AT or GT. V is 0, U is unknown, gravity is negative 10, and time is 1.5. So I got a 0 and negative 15. So U become 15 meter per second. So you saw, students, sometime we need this to find. So some student try to get this value from here. Not possible. Sometimes we have to go reverse question. Reverse question means start from here, get the time of this time subtract from total 2. We got this time is a 1.5. And we can work on to get the required target. You see, diagram will help you a lot. So I just again, please make a diagram and write data. Find distance traveled by the particle between the two times when its speed is 10. Again, I will make the same story. Okay. Okay, so this is the same data. Data is not changing. So copy and paste here. Okay, this is done. Now, student, you know it very well. Why it is a traveling. Hold on, is a distance travel when speed is 10. Okay, so you know this is 1.5 speed. I know now. This is I think 15. I got it. There's no mistake at all here. Okay, and what situation, students? Let me write this one first to make diagram. So this is a position. This is a position when it was traveling upwards. So at this moment, its velocity is what here? 10. Okay. And same while traveling downwards. At this moment, what is velocity? Again, 10. So velocity 10, I will talk about this motion now. Student, I will talk about, and now this 10 will behave as a U. 10 will behave as a U. So this is a 10 velocity here. So this motion, when you talk about, I want to find this because what is the target? To find distance, and find the distance traveled by the particle between two times when the speed is 10. So let's start. Speed is 15, 16, 17, 18, 19 here. Suppose, sorry, it is going, our speed will reduce 15, 14, 13, 12, and here 10. And it's slowing and stop here and now accelerating again 10, 20, and 40, sorry, 1, 2, 3, and 10 comes here, same position. So it means that 2. So first of all, if I find this distance into 2, I'll get my answer. Repeat. This distance, I get it, and this distance, both are same. So if I get this distance and I will into 2, will get my answer. So this velocity is a 10, will behave as a V. Actually, this given here, so this will behave as a U. So going upward, naturally, gravity is -10, that you are familiar. So let's start. So S is equals to ut. Oh, I think I can use the other formula because VU both have a 2AS is equals to V squared minus U squared, going upward or here -10, and S is a target. Last velocity is 0 and here 10. So I got at S is equal to -100 by -20 to cancel, and I got a 5 meters. It means, student, this distance is a 5 meters, and this is also 5 meters. So total distance traveled. Total distance is what? 5 into 2. And I got a 10 meters. So alhamdulillah rabbil alameen. I believe you got a point very, very clear. Let's go for question number 3. A crate mass of 600 kilograms is being pulled up. It means it's going up. Okay. So there is slope of rough plane, constant speed. Okay, constant speed means acceleration 0. And constant speed is what? I write even that speed is 2. We mentioned here. And rope attached to a winch. The plane is inclined an angle 30 degrees horizontal. So let's try to make a diagram. Because without diagram, you know, I never start the question even. Okay, so let's have a look now. Okay. So student, what is this angle? Is a 30 degree given by him. Okay. And further, what is said? He said that the winch is working constant rate. Power is given by him. Power is given 8 kilowatt into 1,000 become 8,000 watt. Okay, coefficient friction is our target. So mu is our target to find it. So let's work on a crate. So let's say a crate, this kind of crate. So this is applied force. This is naturally friction force. This is mg sine theta. What is the mass? 600. And basic formula mg sine theta. So I'm writing the top mg sine theta. So I'm writing here m is 600, g is 10, and theta is 30. So if I type mg sine theta, so m is 600, gravity is 10, sine theta is a 30. If you type, because as a teacher, I know sine 30 is half. Half will cancel this 5. And if I type this only in calculator, so 6,000 into half, it give you us 3,000. So this mg is 3,000. You see, I calculated best way, you make it separate here. So you can say there's a weight component acting downwards. So, or this okay, no problem. 3,000. Okay. Now friction is, I don't know. Applied force is very clear, but problem of applied force here, power given. You know, we have a special formula. This is a weight component, weight acting downwards. The student, what is the basic formula we have? The basic formula for the power we have given is a force into velocity. Okay, and if I bring this velocity under the power, so power by V is equals to force, and power is given 8,000 and speed is given, 2. So it means I can find power easily, 8,000 divided by 2, and I got a 4,000 Newton. So let's apply a formula because system is going upward motion word I'm writing here for you. Just arrow is enough in exam. So I'm going to complete the question now. Basic formula we use in this kind of questions are net force is equals to MA. Applied force minus friction force minus mg sine theta with the weight component equals to MA. But as you know, constant speed, so acceleration is 0, as I said before, on the top. So right-hand side is 0. Applied force, I just got it, which is a 4,000. Friction force, I don't know. And this, I got it, 3,000. You can see even here. Okay. So 3,000 and air mass is 0. So this, I get a 1,000. And I will bring friction on the other side. And now student F is equal to 1,000. And it means, and what is the fuel? F is equal to mu R. And thing is only what is R? R is what here? This word R is acting upward, and this is called mg cos theta. Mg cos theta. Mg cos mass is a 600, G is 10, and cos 30. If you type this whole thing in a calculator, 6,000 into cos 30, it give you it's give us, because actually cos 30 is what? Cos 30 is root 3 by 2. So root 3 by 2, this is a root 3 by 2. Okay. And 6,000. So I got a 3,000 root 3. Okay. If you type all together in calculator, maybe it will not give you that answer. It give you 5,196. No problem at all. Both are correct. But you know why I'm typing this way, students? Sometime he asks you exact answer. He's not asking exact answer. If he asks you exact answer, then you can't type in calculator. If you type in calculator, get a not accurate answer, because you will lose accuracy, because root 3 is a 1.7321. So that is why, students, I'm checking this value here, just showing you the concept. So I'm getting here 3,000 into root 3. I'm covering the both concepts. Like if you have this question come for the more accurate answer, 3 zeros cancel. So 1 over 3 root 3. This is my exact answer, but because in this particular question, if you write as it is, no issue at all. And 3S, this is exact answer, but he did not ask for exact answer. Then 0.192 3SF. And I believe you got a point clear. So you can write anyone, so because he did not restrict us. Anyway, let's go question number 4. Okay, question number 4. Please listen up carefully. Some students ask because that force, how we can resolve this one. Let me tell you, all force acting along x-axis right side or left side or upward or downwards, no component resolving, make sure. Okay, only acting in the middle of quadrants that we will resolve, only make sure. Okay, so this is has a no component, this is a no component, but it has a component. Another question student asked me regular basis. So how we know which is the cause? It depends upon the given angle. In this question, he tests your knowledge. This is a 45. And where angle given, that force is always cos component, 2F cos 45. And which is angle? Look, angle given here. So cos, angle not given here. So it's a sine. So this is a best way to understand sine 45. Let's talk about this. This again, look, the examiner very cleverly, he given us theta here now. If theta here, students, so this is a cos component. And theta not given here, so this is a sine component. So students, I believe you got a point very, very clear. Okay, so let's try to do it. Because system in equilibrium, so I can say rightward forces equal to leftward forces. So I can say these two forces, this is right side, this is the right side, this is the left side. And I will make them one equation. So let's start. First, I'm dealing with the horizontal components. So horizontally, how we can make this horizontally? This plus this equal to that. So I'm writing here 30 cos theta is equal to 3f plus 2f sine 45. This is sine 45, it's not a, okay. All right. And I'm leaving this as well. Let's talk about vertically. Vertically means up and down. This is up and these two forces acting downwards. So I'm writing here 30 sine theta. And this plus that. Okay. And I think so you can see that we have techniques, okay. Two techniques, sine square plus cos square. This plus this one even, but it's a lengthy process here. I will do another way. And what is that? Sine over cos is 10. So this equation number 1 and this equation number 2. I divide 1 by 2 is make question easier. So what is the rule? The left-hand side will keep it up. Look, student, I'm writing. I believe, inshallah, understanding. So this up and this up. And I'll take f common from here even. This make, inshallah, easy to understand, easy to solve. And this whole equation I will write under it. So 30 cos theta. You can ask why, sir? Because sine by cos is a 10. Cos by sine is not a 10. That is the logic behind it. So 3 plus 2 sine 45. How I got it? This f common out. So this 30 cancel. I got a tan theta. F cancel. And I can find easily. I can find easily from here. The next the answer from here. And have so we get the answer, student, after typing it in calculator. So if I type in calculator 1 plus 2 cos 45 degree and 3 plus 2 sine 45 degree. So I get the value is coming in decimal form 0.546918. And take a tan inverse of this, I get a theta 28.675 degree. And writing 3SF, he's asking for theta 3S, sorry, 1 dp, 28.7 degree. And he asking further, find out the force. So I will not use rounded one. I use without rounded, okay? This I can plug in anywhere. I can plug in here, okay? Or I can plug in it here, no problem at all. I put in 2 or even 1, no issue at all. Put in 1. So 30 times to sine 28.675 equal to F common and 1 plus 2 cos 45. I have taken F common. Now, students, what I will do, this whole will divide. And when I divide, it will turn to be this format. And now it's matter of typing in calculator. So what F answer I'm getting here? So 30 times 2 sine and divided by 1 plus 2 times 2 cos 45. And answer is turned to be 5.9627. After rounding, 5.96 newtons. Okay, and I believe the point is very clear. And let's go for next question number 5. Question number 5, what a question 5 here. He said that particle moves straight line starting from O. Okay, naturally when, okay, so when start from O times 0, okay, S 100% 0, but velocity not 0. Reason, if I put time 0 here and 0, velocity will become 1. Okay, this is just for extra knowledge. It said that leaving this formula, but this formula is applicable from 0 to 4 seconds. Okay, and you may assume that velocity of the particle is positive 0 to half. Okay, and it's 0, and add 0 is a half, and negative bigger than half. All right. Okay, and he asking distance travel between 0 to half. You know, students, best technique, I show you this equation. I just let me take a question, and I just type in the calculator, I mean graphical calculator, and hold on, students. Yeah, I'm going to show you this MOS calculator or any calculator, graphical one. So if I type x to power 3, okay, and negative 9 divided by 2, okay, and times 2 t square, I mean x square, okay, and plus 1. You see, students, this is my graph, okay, and he talk about, if you look at carefully, I show you the concept, what he talk about. So students, if you look at carefully, so he talk about this is a this is a this is a point. This is a point when it is a this area is above x-axis. So this is a positive, and but this area whole is below x-axis. So this is negative. Okay. And so he said here, let me show you because he said here 2 here. There's a 1, there's a 0.5. This is talk about half. So this area starting from 0, ending at half. So this full area coming positive, and so we can do it directly from there. So have a look, students. It means first part not an issue because 0 to half. So I will, what are the 3 criteria? Displacement. If you differentiate displacement expression, you get velocity, just a revision of the topic, and velocity expression differentiate, you get an acceleration. So differentiate, level up. If I want to come down, so integrate. So I hope so got the point. Currently, I'm velocity level. I want to come down and finding distance or displacement. I must go for integration. So let's try to find it. So if I integrate the velocity, I'll get S. I'm writing S here. And limits 0 to half and t cube negative 9 by 2t square plus 1 dt. So when I increase the power by 1, so power 4 by 4, increase the power by 1, so 3 by 3 by 2 already present, and this is a t, and limit 0 to half. And student, I just plug in the numbers. When I plug in 1 divided by 2 and power 4, wait a minute, NO4 and negative, this 3 cancel with this 3, I get a 3 over 2. So 3 into into 1 over 2, and the power is 3. And down I have a 2, okay, and a plus 1 over 2. My answer is coming with me 21 over 64. 21 over 64, and if I plug in 0, I get a 0. So this is a 21 over 64 is my answer number 1. And if you check in calculator, is giving us 0.32125 meters. And I believe the point is clear. Total distance traveled between, so we have done it. Okay. So same method, we have 4 marks finished, and let's go for the next part. Next part is we have a B. Next part B, find positive value, find the positive value of t. So t is our target. He said positive. So time could not be equal to 0 and not even negative, he's saying. So in which the acceleration 0. And so first of all, acceleration. So look, student, I just discussed with you, if you are on the velocity level, you need acceleration. So what to do? Obviously, differentiation, I will go for it. So I will take this whole equation with velocity, I will copy, and so this is velocity I have already. I will differentiate. I'll get acceleration. And what is differentiation criteria? power will come multiplied down and power 1 less 2. So 9 over 2 is already power 2 is comes down and power 1 less. And this 1 becomes 0. Okay. This cancel out. I get acceleration 3t squared negative 9t. And he said that acceleration is 0. So I'm going to plug in here 0 and saving my time. So what is a common? 3d common. I get a t minus 3 is equal to 0. Either this is 0 or this is 0. So I can say 3t is equal to 0. Or t minus 3 is equal to 0. This is a t is equal to 0. Not possible, I said before. So time becomes 3 seconds. So this is my answer. And Alhamdulillah Rabbil Alameen. Now he said further extra part. So find the distance traveled from 0 to this instant. So it means I will again integrate. It means the point is very clear. So I will find out there's the same expression. I will copy and I will paste because again, I'm finding I need to integrate it. But important part is that not 0 to, okay, but problems, you know, very well. I just showed you now that a half part, there's some part, there's a half, till half, it is above. But bottom, if you go down, okay, if you go down, so till 3, it is below. So this is a positive area, there's a positive section. And what about this is a negative below x-axis, a negative area. To eliminate the problem, so what we'll do, students, so what I will do, I have a first, but here I'm starting this from half, ending at 3. So let me erase this and this, I hope so you got it. Now here I'm writing half. But you know, I will put minus sign. You're surprised to know why I'm keeping negative sign because curve lies below x-axis. This is the main reason, students. I hope so you got my point. And that is why, you know, I made it here positive sign. So negative sign to make the distance negative. You see, inshallah, whenever you integrate, it will give answer. Okay, like for example, increase the power by 1 divided by same, and increase the power by 1 and divide by same. So 3 2s are 6, or I just show you as it is. And here t and increase the limit is half to 3. Okay, this value is when I plug in this answer. So let's see what answers come. Half, you know, student, we have done before. So when I do it on the half, you know, half, I plug in, I got 21 by 64. 21 by 64, 21 over 64. So lower limit, when I plug in, I got 21 over 64. Upper limit, 3, I'm going to plug in. And let me check my calculator. And I am going to type it. 3 to the power 4 in the numerator. And down, I have it. 4, and then minus 3 by 2. So I have a 3, or I can say 9 into 27 divided by 6. Okay, and plus I put 3 here. Okay, I'm getting here 69, negative 69 over 4. You know, 69, sorry, 69 over 4. So student, negative 69 over 4. So ultimately you can observe from here, it is coming negative. And let me find it, negative 69 over 4 and negative 21 over 64. So let me recheck. Yeah, I'm getting here negative 1125 by 64. You saw because it's below is it got a negative. And this negative sign, outer negative sign, just to cancel this negative sign. So I got S is equals to 1125 over 64. So total distance is not this one. So total distance, if I ask, so we have to add them both. So 1125 over 64 come from this section. And the previous one, you can see even here, 21 over 64. 21 over 64. So if I add it here, 21 divided by 64, so answer is turned to be 17.9 meters. And I believe you got a point very clear. So Alhamdulillah Rabbil Alameen. Okay, now student, let's move on. Next question number 6. Question number 6 is what? A car of the mass is 1800 kilogram is towing a trailer of mass. Okay, so there's a best way when you have this kind of question. Okay, especially these two particles are connected. Diagram is very important. Okay, what is said that sine alpha is that? So sine alpha, this is sine alpha 0.05. So he's saying what? And especially when he asks acceleration tension, you have to deal them separate. Okay, and the car mass is given here. So this is a car mass 1800. Okay, this is, I'm showing you the other particle is here. So this mass is a 300 kilogram. Or I make it small, less, slightly small, so you can understand. Okay, okay, this is clear. And tension 100% towards pulley, towards each other. Okay, not pulley is not here, towards each other, right, students? And I think we have done it up till here. Now let's move onward. What is said that there's a friction force 800 acting on cars, so friction. But you know, every particle has a mass and has a weight component. What is this, students? So mg sine theta. So mg sine theta, you know, mg sine theta, mg sine theta. Mass is a 300, theta is g is 10, and sine theta is 0.05. If I type this in calculator, students, so I got a 3000 times to 0.05, which is coming 150. So this is a weight component, I got 150. But he said a friction, this is a friction acting on trailer, and that is given, I think, somewhere here. Let me check. Yeah, given 100. But he said first F, and now he's given currently 100. So I'm writing 100 here. Same way the weight component for the trailer, same weight component that. So this is a weight component. I'm writing this weight component, and there's a friction of the car. Friction of car is given 800. I'm writing all components. And what is the weight component? Same way I have found before. I will find the other one, which is, I think here I'm finding. So mg sine theta. Mass is 1800 this time. You can check in calculator and parallel type with me. And sine theta is 0.05. You can, if you divide your burden, divide your calculation, so you can, it means the chance of mistake reduces. Second, your attention will not divert. So I got it, what here? 1800 into 10 into 0.05. I got a 900 newtons, okay? So weight component is a 900. So now I think what is applied force? Applied force, he mentioned here, driving force is given 3000. So driving force is given 3000. Now, student, I will make it two equations. One is for the car and one for the trailer. Car, what is the basic formula? Net force is equals to MA. So let's talk about how many for a component acting on the car. 1, 2, 3, 4. So net applied force is a 3000 on the top, minus friction 800, minus weight component 900, minus tension, and equals to mass MA. So 1800 times to acceleration. And if I type this all in calculator, then all now numerical values, okay, so I get 3000 minus 800, I'm getting the 1300. 1300 minus tension equal to 1800A. Equation 1 done. Same is true. I will talk about these three forces. So I start, because moving is the particle moving upwards. I'll start from here. Where is moving upwards? Start from there. For example, is moving upwards. I'll start from here for car, but moving upward, I'll start from tension for the trailer. Let's go for that. So tension minus this minus that. So tension, formula, you know it, net force is equals to MA. So I'm writing tension minus 100 minus 150 is equals to mass is a 300 into acceleration. Acceleration we don't know. So I got here 250 equal to 300A. Now, students, I will copy the both equation. I think this equation number 2. Okay, this equation I am copying. Oh, and I paste here. Okay, and this equation I copied. You can save your time in exam. You can write, bring this equation down here. Okay, anyway, no problem at all. Now tension cancel out, and we got what? So out of 1300 subtract 250. and I got a 1050. And here I got a 2100. And divide by 2100, so I get it what? Half. So acceleration is coming sharp half. Okay, this value you can plug in anywhere. I plug in here in 2 to get tension. So put in 2, put in 2. So tension minus 250 is equals to 300 times 2 acceleration half. So this will go there, and this 150 of half of 300 and plus 250. And I got a 400, and I believe you got my point. 150 plus 250 is a 400 tension. At a start, speed is 20. Okay, speed is 20. So speed at the bottom is 20. Okay. And distance is 50 meters. No problem at all. And instead, the total work done against F. You know what does F talk about? If you look at, go back at F. F is given here. The resistance, force, acting or trailer is F. That F he helped here, he wrote here. So this is against F. It means short story, this is a work done against trailer, okay? Work done, okay, I'm writing here, work done, friction force by trailer. So is given 6,000 joules. So it means, students, if I make this diagram, inshallah, I believe you understand, is a height, there's a B for bottom, this is T for top, particle traveling from here, reaching here. So bottom speed is given at a start, he mentioned 20. So here speed is 20. And the end we have to find. So velocity at top is our target. So students, what to do? So basically, we have a formula which I'm writing here, work done by applied force, work done by frictional force, kinetic energy plus potential energy at a top, where it ends and where it starts, B for bottom. Okay, we need all these things. So first of all, work done by applied force, what we have, students. So luckily, applied force, work done, force is given 3,000. So I can find easily, work done by applied force is of F into D. So 3,000 into distance 50 meters. So I got a 15 and 40 joules. Okay. Now work done by friction force is a one by the car and one by the trailer. Okay. By the car, trailer is given by him. Car by what? What is the mass of car? Is 80. Trailer is I think 300. If you add them, become 2,100. And friction acting on a car is, I think, 800 newtons. So that 800 friction force into distance. So 800 times 2, distance 50. And this is given by him already. You see, this is joules. It means this is no need to calculate, given by him. So if we calculate 800 into 50, let me check the mass of car. Sorry, friction is 800, correct. So small f into d. This is small f into d. I'm getting here, and if I add plus 6,000, so I'll get here 46,000. Okay, joules. Okay, student, I think so clear. All right, this is done. And let's go for kinetic energy at the bottom, B for bottom, half mv square. And mass I will take together, and mass together is coming 2,100. So half into 2,100 into 20 square. And I get it what? 42 and 40 joules. And what is kinetic energy at a top? So that is a target to find. I don't know V. So I got a, sorry, this is a 2,100, not 1,200. So 2,100 divided by 2, and I got a 1050 joules. Sorry, V also there. Okay, now student, one part left only that we have to calculate even. And what is that? Potential energy on the top. There's mgh. Mass is m, g is 10, h I want to find. But student, you know it very well. If I use this triangle opposite by hypotenuse, hypotenuse is 50. So I can say this is a 50 equal, and sine alpha, we know is previous part 0.05. So I'm just sine alpha. And this value, we put it here, and 50 multiply, I get a 2.5 meters. So this is a 2.4. What is a 2.5? So 2 into 100 and one more 0 into 2.5. I'm getting here 52500 joules. I student plug in all values. Applied force is where's applied force? Let's find it. Is this? So 1540, and this I got it here. 46000. Kinetic energy on the top is here 1050 V square. Potential energy at the top is this 52500. Kinetic energy at the bottom, and that is here. So 42 and 40. Potential energy bottom is 0 because height is 0. Now, students, I'm leaving 1050 here and I will bring all other values. So let me type it in calculator. And minus 4, 6, and 000, and minus 52500. Okay, and plus 4, 2, 4 zeros, and I get 471500, and divided by 1050. And then take a root of the whole answer, and my answer is coming with me 21.19. It becomes 21.2 meter per second. I believe you got a point clear. Question number 7. What question number 7 we have here? He's saying the diagram mentioned, okay, and particles P and moves, both masses are kilograms, okay, and plane is inclined, okay, and sine theta is 0.6, okay, and the length of AB is 0.75. Length of AB is 0.75, and the length of BC is 3.25. Okay, this is very clear mention. The section AB smooth, it means here no friction at all. And this is a rough, so here we have our friction is not equal to 0. And given this mu, so mu for this portion is 0.25. And he said particle release from rest A and the same instant Q release. So both velocities are velocity of P is 0, velocity of Q is 0. Okay, verify the P reaches the B at 0.5 second after it releases with speed of 3. So let's see that how to get it. P particle. So let's try to do it. If we talk about P particle, first of all, we needed this is particle here. A particle is mass. I don't know mass. So what is the weight component? It is, always we write always mg sine theta. Mg sine theta. Okay. And sine theta, I think given by him 0.6. So mass is a mass and 10. So 10 m times 2 0.6 becomes 6 m. So this is 6 m is a very clear, and friction is nothing behind. So net force is equals to ma. So 6 minus friction is equals to ma. Mass is this, acceleration's target, but friction is not there. I can write this one. Okay, 6 m, sorry, I missed m here. So this is 6 m. Okay, students. So 6 m. Okay, 6 m. Mass cancel, acceleration becomes 6. Okay, student, it means that if there's no friction, acceleration is 6. So we have data u0 and acceleration is 6. And we have to find distance is 0.75. 0.75. I need to find out what time and speed. So both target we have to fulfill. So it's very clear. V is equal to U plus AT. V is a target. Sorry, we can't use this formula. In the beginning, we have to use the first one. S is equal to UT plus half AT square. 0.75, U is 0. And acceleration is 6 and time is unknown. So this is 3, will divide and take a root. 0.75 and divided by 3. And let's calculate it. So 0.75 divided by 3, and I get my answer half. So proved. He was asking this, find out this time is proved. And this answer, I'm going to plug in now another formula, and that V is equal to U plus AT. V is unknown, U is 0, acceleration is a 6, and time is 0.5. Half into 6 is 3. So Alhamdulillah Rabbil Alameen is also proved. Okay, so let's go for the next point. Okay, so let's go for the next point. Find the time it takes the travel for instant two particle release until they collide. So now, student, what I will do, I will show this diagram. Collision may be somewhere here. So let's talk about step by step. Okay, so until they collide. So let's see. Step number 1, this is a P particle, this is a Q particle, and I show you 3 to 4 steps. Okay, so I make this diagram, copy, and I make paste here, and I make paste once again, I paste here. It will take time. Okay, students, so okay, I think one more time. Okay, so students, P is traveling from here, and this is a gap, you know, I think this is a 0.75 meters, 0.75 meters. So this particle reach here, and it will take time. How much time? It will take time half second, and velocity at this moment is 3. P particle. Okay, Q particle will start from here, and it reach somewhere here. Okay, and it is a Q particle. Okay, and so at a half second, let's say at half second, it reach here. Half second, it will reach here, and this half second reach here. After this P is here and Q is this position, let's say next stage, this P will start from here and reach here with a collide, and Q will start from here and here reach, there's a collision here coming. Here we have a collide. Okay, so collision is here. So now let's see, students, it means this is a time already we have it. So this time for this journey and this time for this journey are equals to each other. Okay, and this gap, you know it very well, 0.75. So if you look at carefully, students, I need to find now the Q particle also. Q particle has a rough surface. So let's find it. The thing is that for the Q particle, what's the mass? Mass again the same. So you know this same. So this 6m. So it's not changing. But backward we have a friction, and what I can say is 6m minus friction. First the friction, you know, mu r. R is what? This is a 6 mg cos. Look, I'm writing here mg cos theta. But sine theta I have it, and I can find the cos theta easily. How? So 1 minus sine theta whole square root. If I type in calculator 0.6 square, it give me 0.8. Let me recheck. 1 minus 0.6 square. Yes, it is giving 0.8. So mg is 10, and cos theta is 0.8. It is giving us what, student? It give you 8m. So this is 8m. Let me find it, check once again. Yes, 8m. So R is coming here, 8m. So, but friction force what? F is called mu R. So mu R. So this into this. So 0.25 into 8m. Okay, student, this is a net force I'm writing here. What is the basic formula? Net force equal to MA. And what is the mass? Mass is M, acceleration is I want to find. And okay, look, student, I will type in calculator, mass cancel. So 6 minus 0.25 times 2, 8. And I get a, wait a minute, let me check again, 6 minus 0.25 into 8. Yeah, it's coming with us 4. It means whenever particle will move along the rough particle surface, throughout remain 4. Either the P will reach traveling here or Q traveling here. Acceleration remain 4. So I'm writing now here for the Q particle. So starting speed 0, acceleration is 4. Okay, how much it will travel here? You know, I want to find out total distance. You know, from here, so this distance. Okay, speed. Hold on. Let me tell you one thing. What is the basic plan here, students? acceleration for this is a 4, whereas acceleration for, okay, now same manner, I have to go for, look at here now, u is equal to 4, and I want to find out, because q is traveling, and what is a speed at this moment. Okay, that is very important. So let's find out the speed is what moment when time is half second gone. So v equal to u plus at. V is target, u is 0, acceleration is 4, time is half. So velocity at this moment is 2. So velocity at this moment is 2. Okay. All right. And this time is, it is a half second. Okay. Now, students, what is the time? And now it means at this moment, so can I say distance traveled from here and distance traveled here? Okay. So let's work out for this plan. I think up till here understanding, and now I make what is the particle speed at this p is 3, and I want to find out the because distance are distance for p from here to there, and okay, I can say that, you see, this distance of q particle and this distance are equals to each other. So let's find for the p particle. Now for p particle, but make sure this is starting 0, but here 3. So for this motion, the starting velocity for p is 3. I'm writing here starting squared 3, and time is I don't know, and distance, and wait a minute, yes, and I get an acceleration. What I said before, it remains 4 throughout because rough surface. So now I can find, so what is the formula? S is equal to ut plus half a t square. U is 3, time is, I'm leaving as it is, half times 2, 4 times 2 t square. And I get finally here what? 3t plus 2t square. This is a distance by the p particle. Okay, students. But important part is what here, the most important part. Okay, that is part is, for your knowledge, the time for this q particle is not t only, t plus half. Okay, so I'm writing now for q. So u is 0 and time is 0.5, or you can say 0.5 plus t, and acceleration will remain 4. So s is equal to ut plus half a t square. U is 0, half, it is a 4, and time I'm writing here t plus 0.5 and square. So I got what, student? 2. I got is 2, and in the bracket, if you expand it, I just tell you directly, first term square, 2 into first term second term, I get a t, and 0.5 square giving us 0.25. So multiplying inside 2t square plus 2t and into 2, I get a 0.5. Okay, now student, this is SQ, okay, SQ. So it means they are equals to each other. Naturally, this distance by p particle and this distance by q particle are equals to each other. And I'm going to plug in into each other. So when I put them equal to each other, so let's see what happens. So 3t plus 2t squared equal to 2t squared plus 2t and plus 0.5. This is cancel out and it goes there, and time become what? Time become 0.5. It means, student, this time is understood 0.5 and this time is understood already 0.5. So time for P to travel here to here is 0.5 and Q is this 0.5. And 0.5 and 0.5 become 1. So Q particle will take is a 1 second and this is a 0.5. All right, and 0.5 and 0.5, 1 second. So it means this total time, how much it will take, because he was asking us find total time. So 0.5 plus 0.5. So total time is 0.5 plus for both particles are 1 second. I believe this part is very clear. And let's talk about the two particle collides. Okay, after the collide and collision of the coefficient of friction between the combined particle is the same. Find the time it takes to instant from particle collides until the particle reach C. So it means we have to consider now C also. Okay. So let's see. First of all, we want to know that it is in the middle somewhere. It will collide. Okay. So first of all, what is the plan of action? How we can start? Two particle collides when they collide. So, first of all, we need to find out the velocities of the both particles before collision. So, I'm writing here before collision. I'm writing here after collision. Okay, before collision, there's a P particle, and this is a Q particle. And after they will become together, you know it very well. Okay. And this is a mass m kilogram, m kilogram is m kilogram. Okay, what is this speed and what is this speed? Just after this is a speed is 3, you know it very well. This speed is 3. And I think I tell you one thing, it is okay, 3. And what is the speed? You can see that P is traveling this way. Q is here. And what is the speed of the both particles just before they collide? This is very important to know. And the P speed is what? So for that data, I have to work upon this concept here. P particle is here. So this is a very important, okay, just before collision. And time for just for collision is what time? I am making a plan here, and I just tell you. For the P particle here, so time is what, student, is a 0.5. You can see this one. Time to reach P is 0.5. And let me show you which equation we can use. This equation, okay, first of all, we need two things. First of all, velocities just before hitting. So which equation we can use? This data is given here, and time is, time is 0.5. Look at now using here. I need time. So V is equal to U plus AT, and V is a target. U is 3. How 3? Look at now. The U is 3 given here, right? And acceleration is a 4, as I said before. And time is, we have, time is a 0.5. So let me check, is it 0.5 or 1? Hold on. Yeah, it is traveling from, not from here, from there to there. So I will take a 0.5. So I will take her here 0.5. So 3 plus 4 times 2.5, it is giving us 5 meters per second. It means just before hitting speed is 5. And what about Q? What about Q? So for that reason, I will concentrate here. And because Q is traveling, so from here to there, I will, for T, I will take a 1 second here, okay, not 0.5. So for Q, time I'll need it. So velocity is equal to U plus AT. And U is 0, acceleration I4, and time is 1. Okay, so this is a very clear. And if I take it, this 4 meter per second velocity, 4, okay. And what is the formula? This I'm writing U's, okay. So U1 and U2, and so M1 U1 plus M2 U2 equal to M1 plus M2 because squareless. So this is a 5 times 2M and 4 times 2M. And here I got M1, M2 same. So I'm not writing here M1, M2. Both are 2M. And this is becoming 9M and here 2M. So MM cancel and velocity become 9/2. Okay, meter per second. It means just after hitting this speed become 9.2. So 4.5 even you can write. So this is clear, student. But what is the target to do it? He said that find a time instant with the collide until they reach the particle C. Now, student, I will plug in how much travel it will travel to reach here. This is important with a collision. For that collision, if I plug in this formula, because a P particle, if I plug in 0.5 here, so what answer? So as this equation, I take it down. So this is a copy, and I take it here. Okay, so at time is equals to 0.5. How much SP? So 3 times 2.5 and plus 2 times 2.5 and T square. So 3 times 2.5 and plus 2 times 2.5 square. I'm getting here 2. So 2 meters. So 2 meters is there. 2 meters. It is a yeah, okay. And I want to know how much it will travel further down. You see, look at here. It means it's a 3.25. It will move how much where collision will happen? So 2 meters. How much distance remaining, students? So 3.25. minus 2, so 1.25. So how much distance left behind? 1.25. So let's start 1.25. So how much remaining distance? You can say here. So distance from remaining distance, how much? So it means to, wait a minute, let me see again, 1 minute. So as a 3.25 minus 2, 3.25. So I got 1.25. Now let's talk about the chorus happen, and now we'll see what is the starting speed, because the combined speed is behaving as a U for the next motion. See, so this is a combined. They will travel this way. Look, I'll show you. So this is a starting speed I will take, and here and this distance is naturally, we know it now. So now it means this is situation, students. So distance from here to here is 1.25. Okay, and acceleration remains same as I said, because they are inclined plane, same rough. Okay, and this is starting speed. I will take what here, this speed is at 4.5. So let's start. What is the formula? We need to find what here? We need to find time taken. Okay, time taken. So V is equal to, sorry, not V. We use S. S is equal to UT plus half AT square. S is what? 1.25 and VU is what? 4.5. This is unknown. And here I'm writing was unknown. So I got what is a 2t square. So 2t square plus 4.5t and negative 1.25 is equal to 0. So student, I'm going to just a minute. Okay. So I will just okay. Now what is a value, student? 2. I plug in a quadratic equation. So t is equal to negative b square 4a c negative 2.5 by 2a. So when I apply formula, student, I got two answers, 1 by 4, negative 5 by 2, and 1 by 4. This I have to ignore, and this is a time 0.25 seconds. So Alhamdulillah Rabbil Alameen, I believe the point is very clear. Paper is completely over. But I just tell you once again what a story he is asking, because you see this question is a little bit tough, but diagram make the question easy. Okay. And make sure the Q will travel only and only 1 second, because 0.5 here and 0.5 here. So whenever I need a Q distance time, I need a 1. But P is not, P is, this is a 0.5 and this is a 0.5. So it means Q will also take 1. So I think, but for this distance, if I need for P particle, I will not take 1. I will take 0.5, make sure. So the whole story is very clear, and I hope so. So this is a after collision, you know it very well. So after collision, this starting speed is what here? Starting speed is here is okay. This is the previous part here. So this is given 4.5. I hope so. The paper is clear, and the best of luck for exam. And assalamu alaikum wa rahmatullahi.